Hello everyone, welcome to KT Academy. Why we need to improve power factor? Let's see that. There are three types of load: resistive load, inductive load and capacitive load. In resistive load, the phase difference between voltage and current is 0. For resistive load, the phase difference between voltage and current is 0. So phi is 0, Q is equal to VI sin phi, Q is 0. So reactive power of resistive load is 0. Neither it consumes reactive power nor it delivers reactive power. For inductive load, the voltage, there is some phase difference between voltage and current. Current lags voltage by some angle depending upon the value of R and L. So the inductive load consumes reactive power, whereas in capacitive load in which the current leads voltage by some angle, so there is some reactive power, it delivers reactive power. Now consider a practical example. Let's take a load. Normally, practically our load is inductive. So it demands real power as well as reactive power. Real power for the mechanical energy, that our load converts electrical energy into mechanical energy, which is represented by resistance. So it needs real power, it needs reactive power. So both real power and reactive power is demanded by the load only. The real power and reactive power of the load is only delivered by the generator, that is a synchronous generator. Synchronous generator, when it is overexcited, works at lagging power factor. It delivers real power as well as reactive power, which is transmitted only through the transmission line. There is a transmission line which is having a sending end voltage and receiving end voltage. The reactive power, the receiving and reactive power QR is equal to, when R equal to 0, when transmission line is considered to be a lossless, then reactive power, receiving and reactive power is Vs minus Vr upon X minus Vr square upon X. Vr upon X is common, Vs minus Vr. So reactive power, receiving and reactive power is directly proportional to Vs minus Vr. When inductive load increases, the demand of reactive power increases. When demand of reactive power increases, the drop in the line increases. The voltage drop in the line, which is not good. If we needed 400 volt and it is transmitted by the transmission line, that is sent at 400 volt, but there is a drop and we received only 350 volt, that is not good. So we need less voltage drop. For less voltage drop, QR should be less. It is only possible if we place a capacitance in parallel to the inductive load. If capacitor is placed in parallel with the inductive load, the reactive power demand of the inductive load is fulfilled by capacitor. So the reactive power, the receiving and reactive power of the transmission line reduces. If reactive power of the receiving end reduces, the drop in the line reduces, which improves the voltage profile of the transmission line. That's why we need power factor improvement. In power factor improvement, we place a capacitor bank or synchronous condenser in parallel to the inductive load, which improves overall power factor. Hence, the voltage profile of the system improves. Thank you so much.